Okay, so 20, to talk about charge, then the charge actually is the difference between proton and electrons. Okay, proton and electrons. So proton has a positive charge, electron has a negative charge. Again, now we have a 10 positive charge and we have a 10 negative charge. So positive charge and negative charge are canceled. Obviously, this guy is a 0. And the default setup is 0. So if you don't write anything, that means the charge is 0. Okay, yeah. So now that is going to be the symbol for this isotope. Again, what is the difference between isotope and the atom? If you write neon and the 10 over here, the 10, that means just the neon. If you write this is only telling us, okay, this is an atom, this is near elements. We don't know what kind of isotope it is because they're not shows mass number over here. So this is only talk about neon atom, okay? But it's not specified what kind of neon isotope it is, okay? Okay, let's do 2 more and then we go to the next part. This one is a 12 proton, 13 neutron, and 10 electrons. Again, proton number is atomic number. 12, number 12 is magnesium. Okay, magnesium is number 12. So you can write 12 underneath over here. And the top left, you're going to write the mass number. So mass number over here, again, that's gonna be equal to the proton, which is 12, plus neutron, which is 13. So totally they have a 25. So you're going to write 25 on the top left part, okay? 25 on the top left. And then the last part, do we have any charge? Do we have any charge? Again, proton has a 12 positive charge. Electron now is 10. So we have a 10 negative charge. 12 positive charge, 10 negative charge. So overall is a positive or negative. We have a more positive charge, right? So overall, we're going to have a positive charge. Okay, how to do the calculation? The charge can be calculated by the proton number minus the electron number. Okay, yeah, so this is generally as an equation. Again, you have a 12 proton and a minus 10 of the electrons. So totally we have a 2 positive charge. Okay, totally we have 12 positive charge. So 2 positive charge. So that's why you're gonna write 2 plus over here. You're gonna write 2 plus over here. Okay. Last one, let's see again. Proton number is 15, neutron is 16, and the electron is 15. So proton 15, let's see what kind of elements. That is a phosphor. 15 is a phosphor, okay? And then you can write the 15 over here. And the neutron and the mass, again, mass number is 15 of the proton plus 16 of the neutron. So totally we have 31. So I'm gonna write 31 of here. Is there any charge? We have 15 proton and 15 electrons. So there's no charge, then you don't have to write anything. Then that is gonna be the symbol for this kind of isotope, okay? Yeah, again, if we call this, and we are call neon 20, you need to write down what is the mass number, neon 20. And this one is phosphor 31, okay, phosphor 31. All right, so this is kind of like a review about the atom structures. We reviewed it again about those atom structure. Then let's look at the next next review, which is the atomic, the average atomic mass. Average atomic mass. Okay, so here let's look at question number 8. Again, remember, did you still recall when we do the lab? how to write average atomic mass. Okay, average atomic mass generally is, that's really depends on how many isotope this element has. Okay, so for example, number 8, we have 1, 2, 3, 4, 5. We have 5 isotopes. Okay, which means you're going to list each of the isotopes. This is a 40 titanium, 46, 47, 48, 49, and 50. Okay, so this is the isotopes, and then we need to know what is the mass. What is the mass for each of the isotopes? Okay, what is the mass for each of the isotopes? And we also need to know what is the abundance. Okay, what is the abundance? Abundance, that means what is the percentage of this isotope are in the total isotopes? Okay, what is the abundance of this? Okay, so the mass of each of the isotope, generally we said, if the question didn't give you the specific mass for each of the isotope, then you can use the mass number as the mass of each of the isotope, right? Why? We talk about the mass number generally is similar to the mass of each of the isotopes. That is why we call them mass number. Okay, mass number, because this number is pretty close to its mass. If the question did not specify what's the mass for each of those isotopes, then you can use the mass number to write as the mass. But obviously, if the question shows you what is the mass for each of the isotope, then you don't have to use the mass number. Are you clear?
Yes.
Okay, yeah. So this mass number is just 46 AMU. And this number is 47 AMU. And the 48 AMU, 49 AMU, and the 50 AMU. Okay, so that is the AMU for each of the isotopes mass. And abundance, well, abundance is already shows up there. That is the abundance for each of the isotopes, 88.0%. Okay, yeah, I hope you're gonna write down the percent of there, because the percent is not a unit. It do have a meaning of there, okay? So 8.0%, that means 8.0 divided by 100. If your calculator do not have a percent sign, then this is the same expression, okay? So 8.0% is just 8.0 divided by 100. So generally is 0.08, okay? So 8% is just equal to 0.08. Okay, 47%, 47 AMU, for the titanium 47 as a 7.8%. Titanium 48, they have a 73.4%. And then 49 AMU, that's a 5.5%. And the 50 AMU, the 50, titanium 50 has a 5.3%. Well, so if you look at the percentage for the abundance for each of the isotope, you probably can realize, oh, titanium 48 actually is dominant in the whole isotopes. Does it make sense, right? Because this guy has a 73.4%, which means if you have a 100 atoms for the titanium atom, you have at least 73 of those atoms are belong to titanium 48. Okay, so you see, if one of the elements is dominant, then believe me, the answer for the average atomic mass for this isotope should be close to this number. Well, I'm not talking about exactly the same, but it should be close to this number. Or, I mean, I guess, I haven't calculated this yet, but I guess the average atomic mass for the titanium isotope is about like a 70 something, or close to 90 something, 60, 69 or 70 something. Okay, yeah. So let's see whether this is correct or not. Okay, we talk about if we got the mass for each of the isotope and we got the abundance for each of the isotope, then what are we gonna do? We're going to using the mass of a certain isotope time its abundance. And this mass time abundance, this mass time abundance, the mass time abundance, and this mass time this abundance. Okay, so each of the mass time is abundance, and then you're going to get the answer, and then we're going to add up all this answer together. Then that's gonna be the average atomic mass. Okay, so let's work on this. (46 times 8.0 divided by 100. So we got 3.68. Again, abundance, the percent sign is very important. Okay, so this is the this one number smaller than 1. So once this number time a percentage, you should have a less number than this mass. So we got 3.68. This is AMU. Okay. Next one, 47 times 7.8 divided by 100. Oh. 3.666. 3.666 AMU. Okay, the next one, 48 times 73.4 divided by 100. Okay, 35.232. 35.232 AMU. Okay, the next one, 49 times 5.5 divided by 100. 2.695. 2.695 AMU. 50 times 5.3 divided by 100. 2.65. 2.65 AMU. Okay, so now you got the mass times the abundance for each of the isotope. Then what are you gonna do? You're going to just add up those numbers together. Okay, just add up those numbers together. And then you can see 3.68 plus 3.666 plus 35.232 plus 2.695 plus 2.65. And you got 47.923. 47.923 AMU. Well, okay, yeah, so you got one of the mass, and this mass is close to is a 47.923. Okay, not too bad. Well, at least it's close to the 48, right? Because 48 is dominant in this isotope. So the mass, the average atomic mass for this isotope should be close to this number. Okay, yeah, you see, that is the average atomic mass, 47.923. Again, this is how we do the average atomic mass. And again, next class, we're going to repeat it again. Okay, so we need to repeating the same things again and again. And then you're going to, firmly to remember that. All right. So let's take a break, and then we're going to talk about another things. Okay, let's come back. Okay, let's come back. So the next part again, we're going to talk about the elements and the ions. Okay, what in your hand, I already gave you one of the another supportive material, and this material can be used in the exam. Okay, this material can be used in exam, just like the periodic table. Okay, yeah. So keep this intact. Okay, don't throw this away. This is very important. And if you look at this sheet, and you're gonna realize, okay, and this sheet called common ion sheet. Okay, which means those are those sheets listed over here are all very common, Okay, and they have some kind of ions on shows on the very left part, and also in the first page we have two columns. One column is for this is called the monoatomic ion, which means this ion is only just made by one atom, by one kind of atom particles. And the polyatomic ion on the other side is still ion, but this ion is different. This ion is made by combining different atoms together, okay? And then the overall has the charge. So this is what we're going to talk about in the next part. Last class, actually we already talk about the ions, right? We talk about, especially we talk about how to determine the ions for those A group elements, right? For the A group elements. Okay, for example, what is the charge for the sodium? If the sodium become ion, what is the charge for the sodium? Well, last time we talked about, if you look at the common ion sheet, well, it talk about the sodium should be has a one positive charge. Okay, and we talk about this is also based on the rule. For example, we have a 1A group like a lithium, sodium, potassium, rubidium, and cesium. So 1A group, if this guy become a metal, become ion, they are always has a one positive charge. Yeah. So this is what we talk about it. The charge for the metals usually is equal to their number, equal to their group number. Okay, 1A group will have a one positive charge. 2A group will have a two positive charge. Okay, yeah. So 2A group, we have beryllium, magnesium, calcium, strontium, and the barium. So those guys are all has a two positive charge because this guy in the 2A group. And the 3A, where only just one is a more common, which is aluminum. Okay, aluminum has a three positive charge. Okay, yeah, so which is also equal to their group number. So, and again, we talk about this is only for A group. Okay, not for B group. Okay, not all the B group has a similar charge, just shows like this. Okay, so this one is only for A group, not for B group. Are you clear? Okay, yeah. And again, you can also find the charge of there, but I recommend you're familiar with those metals because some of those metals are very, very common. Okay. And I mean, although you can check on all the common ion sheet, but if I give you one of the elements and try to figure out, you want to try to figure out what is charge for them. I mean, you don't want to, to look at every questions, you're going to go back to look at the common ion sheet, right? Yeah. So some of this, if you can remember, then that's going to be great. Okay, that's going to be great. And also we talk about for the metal, what is the charge for the metal, positive or negative? Metal is always give us a positive charge, okay? So the metal ion always are making a cation, okay? Metal ion always making a cation. They never gave us an anion. Anion as a negative, okay? So metal always making a cation, but non-metal, they may give us an anion. Okay, they may give us an anion. For example, and last time we talked about 5A, 6A, 7A, and 8A. Okay, so 5A group, that's a nitrogen, phosphor, here oxygen, sulfur, and strong selenium. It's a fluorine, chlorine, that's a 7A, that's a 6A, that's a 5A. Okay, so chlorine, bromine, and iodine. Okay, and this is the 8A. 8A, those are all noble gas, helium, neon, argon, krypton, xenon. Okay, so for this, and we talk about if this guy has a charge, I mean, since this guy will always making anion, which is a negative charge, and we're talking about how many number is away. This group number is away from 8, and we talk about 8 is a magic number in chemistry. So this guy 5 has a 3 number away from 8. So that's why this guy has a 3 negative charge. Phosphor will have 3 negative charge. And the 6 has a 2, number 2 away from 8. So they have a 2 negative charge, 2 negative charge, 2 negative charge. 7A, only 1 number away from 8. So this guy have a 1 negative charge. All of this anion, if they become anion, then all of this become a 1 negative charge. And 8, since they are already equal to 8, so they are not going to have any other charge. So those are all zeros. Okay, there's no charge for the noble gas. In another word, this guy will always as an atom. They are not going to become ion. Okay, yeah, noble gas, they are not going to become ions. Again, those are already shows over here. It's already shows over here. Okay, it's already shows over here. And then next part, we're going to talk about another kind of ion. It's called the polyatomic ion. Polyatomic ion, which means this guy is still ion, but they are making this ion is made not a single atom. Okay, what we see over here, you see, what we see over here, those are all just a single atoms, like a nitrogen 3-. This ion is only just made by a nitrogen atom itself. Okay, it's not having other elements over there, like lithium, sodium, potassium. Those are only just single atom. So we call those ion is called a monoatomic. Monoatomic. Mono, that means just one, right? Are you familiar with this prefix? Mono, that means one, okay? Like monosound, okay, monosound, or like a ultrasound, no, monosound. Yeah, the mono is just a one. That means this ion is made by one kind of elements, but the polyatomic ion is made by multiple different kind of atoms. Okay, like what we talk about carbonate, right? Baking soda, carbonate. Okay, the carbonate. This is a carbonate, CO3 2 minus, and nitrate. Okay, or ammonium. Those are all ions. You see, they are having the charge shows over here. So that means this guy are ions. Okay, they are having charge of there. That means that those particles, aggregates, are ions. Okay, they are not a compound. They are not a compound since they have a charge shows up there. So this is an ion, not a compound. Okay, yeah. I would like to emphasize here, there's another one, it's called SO3 2 minus. And let's just see what is difference between this. So let's look at, just only look at those two. SO3 2 minus and SO3. Okay, those are different. Okay, if you just look at their symbols, well, it already shows a difference because this one SO3 2 minus, they have a 2 negative charge. But this one write just the SO3, it didn't write anything of there. It's not because somebody forgot to write the number. Okay, it's not because I forgot to write the charge over here. It's because their charge is 0, which means there's no charge. It's a neutral. Okay, neutral, that means this SO3 is a compound because we say the compound is neutral. But SO3 2 minus, this guy is not a compound. Not a compound. Because this guy has a charge. So they are not a compound. Compound always has a 0 charge. Okay. Instead, this guy SO3 is what we call the polyatomic ion. Okay, this is not a compound, it's a polyatomic ion. They are having the charge, but this ion is made by different atoms aggregated together. Okay, and this, so that is quite different. Okay, please make sure you separate those two. Okay, SO3 2 minus and SO3, those are two different things. And just like the CO3 2 minus, NO3 minus, and NH4 plus. Okay, so polyatomic ion could be a negative charged and could also be positive charged. Okay, so that is the ion. And just to let you know, the polyatomic ion can also able to combining with another ion to make a compound. Okay, the polyatomic ion can also make another combine with another compound, another ion to make a compound. For example, the sodium carbonate. Sodium has a 1 positive charge, and the carbonate has a 2 negative charge. Okay, so the positive charge and the negative charge, and then they can combine together to make a compound. But obviously, we need to the compound. That means the charge should be neutral, and the sodium has a 1 positive charge, but the carbonate has a 2 negative charge. That means we need one more positive charge to balance the two negative charge, right? So that's why you need two of the sodium ion to balance one of the carbonate ion. So when you write that, that's going to be sodium 2CO3. And this 2 means we have a 2 of the sodium ions, okay? This 2 means we have a 2 of the sodium ions. And CO3, that means the carbonate. Well, when you write this as a compound over here, you didn't write any charge. We're not writing charge of there. We're not writing the two negative charge over here. We're not writing charge. That's because the positive charge and the negative charge are neutral together. So the overall compounds do not have a charge. But when those two are separated, they are going to having charge over there. Okay, they're going to having charge over there. Any questions? No? All right. Okay, so let's talk about, okay, so now we talk about the polyatomic ion. We talk about the monoatomic ion. Let's talk about how do we making the chemical formulas by the ions. Okay, so here, this is what we talk about the ionic compound. Okay, the reason we call this ionic because those are made by cation plus anion. Okay, ionic compound is made by cation and anion. Cation has a positive charge, anion has negative charge. So if we have two ions, one cation, one anion, they combine together, they're going to making ionic compounds, right? So let's first talk about the monoatomic ion, right? We talked about this before. We already talked about on last class. Let's just review it. Sodium ion and the chloride ion. Okay, so this guy has a negative, one positive, and one negative. When they are making a compound, ionic compound, obviously, okay, one sodium combined with one chloride, they're going to making a sodium chloride, and the positive charge and the negative charge are balanced. Then they are going to making a compound, right? Well, if you have a sodium ion, and if you have a two negative charge, which is oxygen, oxygen. So you have a sodium and an oxygen. How to making a compound? Well, then what are you gonna do? This guy has one positive charge, but this guy has two negative charge. So obviously, you're going to have another positive charge to balance this. But usually, we're not writing like this. We are having an easier way to do this, which means you're going to having the two, you're moving the two over here to underneath the sodium and put the one, this one charge, and underneath to the oxygen. So we're doing the cross. We're not talking about we're moving the charge. We're just simplify. The two is go underneath this and one go underneath oxygen. So once you write the formula, you're gonna write the sodium and the O up there. But obviously you're gonna move two underneath of this, which means you're going to have a two sodium and a one underneath oxygen. So you put a one underneath over here. One in the chemical formula, the default things is a one. So if you don't write anything, then that means one. Okay. If you don't write anything, that means one. And this is gonna be the formula. So generally, it's the same thing. This is just means we have a two sodium ions to balance the sodium, or to balance the oxygen. You see, sodium 2O. So Na2O. This 2 means we have a 2 of the sodium. It's not talking about we have a 2 of oxygen. Okay, we have a 2 of the sodium. Another one like aluminum. Okay, you can do the same thing for the aluminum. The aluminum and oxygen, well, this one is a little bit complicated, okay? Yeah, so we have aluminum has 3 positive charge, oxygen has 2 negative charge. So now, what again, to make it easier, you're going to just move in the 2 underneath of the aluminum and moving the 3 underneath of the oxygen. So when you write the formula, first you write the aluminum and oxygen, right? You write the, and then you're going to put down the correct number underneath. Underneath of the aluminum, that's 2, so you write 2 over here. Underneath of the oxygen is 3, that means 3 up here. So in this formula, it gives us 5 atoms. In this this ionic formula, ionic compound, they have 5 atoms combined together. We have 2 of aluminum and 3 of the oxygen atoms, okay, in this formula. So if you write the 2 means we have 2 of the aluminum ion. 3 means we have 3 oxygen ions over here, okay? Yeah, so please do not write, okay, we have 2 aluminum and we have 3 oxygen. So this is not correct formula, okay? We never write the chemical formula like this, okay? If you want to represent, we have 2 aluminum in this compound, the 2 have to underneath of the aluminum, which is the subscript of the aluminum, okay? 3 have to under the subscript of the oxygen, okay? Yeah, this is the correct formula, but that is not correct. We never write the formula like this, okay? We never write the formula like this. Well, so I will give you the practice today. Today, the practice generally is just writing the formulas. Okay, I give you the cations and anions, and then you're doing the practice for this. Let's hold on. We haven't talked about yet. We finished everything yet. So now this is talk about the monoatomic ion. Okay, it looks like a monoatomic ion is easier, right? But there are some exception. For example, we have a zinc as 2+, and we have oxygen 2+. Okay. Based on the rule, what are we gonna do? We're going to move the 2 underneath over here, right? We're gonna move 2 underneath over here. So what is supposed to write is 2 and a 2, right? Zinc, and you put 2 and a 2 over there. But for the ionic compound, only for ionic compound. When we do the ionic compound, this we try to make the ratio between the atoms are simplified, okay? We try to make those ratio between the atoms are simplified, which means original you have 2 versus 2. So please write, simplify this 2 versus 2, then you're gonna write 1 versus 1, right? So that is why when you write zinc oxide, you should write zinc oxide, not a zinc 2 oxide 2. Okay, yeah, so we're not writing like this. So you make sure the charge is simplified. Okay, make sure the charge is simplified. Yes. Well, may not be the same. For example, we have a lead. Lead has one of the lead ion is a 4 positive charge, and this is a 2 negative charge. So when you write this, you're putting 2 underneath, putting 4 underneath of here. So you suppose write Pb2O4, but this is not a correct formula. Okay, you also need to simplify this ratio. Original ratio you have a 2 versus 4. If you simplify it, become what? And 1 versus 2. So that is why you should write as a Pb1O2. You don't have to write 1 because 1 is a default. Okay, yeah. So this is the correct formula. Are you with me? Okay, Yeah, so we need to simplify this number. Okay, we need to simplify this, the ratio, simplify the ratio. All right, so this is talking about the monoatomic ion. Looks like it's pretty straightforward. And then let's talk about the polyatomic ion. Okay, if we combine, we have a monoatomic ion combined with a polyatomic ion, then what are we gonna do with it? All right, so let's see. We have a sodium ion here. We have a carbonate ion like this. Okay, what we do generally is the same thing. Okay, so what are you gonna do? Let's see. Okay, this guy, the carbonate CO3 2 minus. This guy also has a 2 negative charge, and the sodium has a 1 positive charge. The CO3. Don't worry about we have a CO3 over here. The CO3, you're gonna assume the C, the carbon, 1 carbon and 3 oxygen is a totally combined together. Okay, they are not going to separate it. They are not going to separate it. You're going to assume this inside is just like a X. So it's Na plus is combined with some of the ion with 2 negative charge. Okay, then you're gonna see we're still going to make the charge balanced. So you should have a 2 of the sodium ions combined together, and then in this case, you're gonna write Na2, and you put the CO3 over here. Okay, yeah. And this CO3 actually is just only 1 carbonate ion. It's not showing have a 3 carbonate ion. Okay, because the CO3 2 minus is 1 of the carbonate ion. We're not going to, it's not 3. The 3 is 3 oxygen inside of the 1 of the carbonate ion. Okay, yeah. All right, so this one looks like easier. Then let's look at another one. That's gonna be complicated. Okay, so aluminum has a 3 positive charge. Carbonate has a 2 negative charge. Then what are we gonna do? Again, right? Well, we're still going to follow the rule. 3, you're going to moving the 3 underneath over here. And 2, you're going to moving 2 over here. Then what are you gonna do? Which means you're going to have a 2 aluminum, and you're going to have a 3 carbonate ions. Okay, I don't worry about you write the wrong for the 3 aluminum ion, but how do we write on the 2 of the aluminum ion? But how do we write the 3 carbonate ion? Okay, so you're gonna write aluminum and a carbonate over there. You're gonna put 2 underneath of the aluminum. That means 2 aluminum ion. But how do we write the 3 of the carbonate ion? You're gonna put the parentheses over here for the whole carbonate, and then put the 3. Okay, I see some of the students, they write that's not the carbonate. You see, the inside is you write CO, not CO3. CO3 is a carbonate ion, not the CO. So if you're writing like this, you completely miss the 3 of the oxygen inside. So this is not 3 carbonate. Okay. So this is not a 3 carbonate. What are you gonna do? Right like this. This number 3 means we have a 3 of the carbonate ions, and this 3 means inside of 1 of the carbonate ion we have 3 oxygens. Okay, inside of the 3 carbonate ions we have 3 oxygens. Okay. I know you will make mistake. Yeah, I totally understand. So that's why we need to do the practice. All right. Okay. And again, today's practice, please using pencil. Okay. You may have a good chance to erase the formulas. So please use a pencil to do the worksheet. Okay. Let's do one more time. How about like barium 2+, and nitrate, barium and nitrate. Again, you know, so the 2 should go underneath over here, and the 1 should go underneath over here. So that means we should have a 1 barium ion, and we have a 2 of the nitrate. So when you write the formula, should just be BaNO3, right? And then you know, okay, we need to add 1 barium, so you don't have to write anything underneath for the barium, but we have a 2 nitrate. So how to write the 2 nitrate? Again, you should have a parenthesis over here and write 2 nitrate, 2 nitrate. Okay, so then you may ask, hey, Dr. Tao, you write a parenthesis for all the compound, but how about this one, the first one, sodium carbonate? Do we have to write sodium and put the carbonate, those ions, put the parenthesis? Well, in this case, you don't have to. Okay? So if there's only just one, this polyatomic ion shows out. You don't have to write the parenthesis. The parenthesis, the purpose of the parenthesis is try to separate out the number from the number inside. Okay? Otherwise, that's going to be pretty complicated. And again, the reason is because when this symbol developed, people using the handwriting. This is a handwriting things. Okay, yeah. In another word, if some of the scientists has a really bad handwriting, then if this guy do not write the parenthesis, the other people probably cannot tell what is the formula they write. Okay, so you have to, if you have the polyatomic ion, you have to have the parenthesis to cover the whole polyatomic ion. And then the subscript of this number means how many number of this polyatomic ion. Very important. Are you clear? Okay, very important. Okay. So this is, well, generally, this is what I want to talk about for today. Okay, we need to do the practice for making a polyatomic ion. So again, I'm going to give you the study guides, and then we're going to do the practice. Of course, I'm going to do some examples for you, and then you can work on this. We probably will leave early. Yeah, once you're done, you can turn in that to me, and then you're done. Don't forget to turn in the rest of those assignments back to me. Okay. And please write your name on this worksheet. Sure. Okay, so let's look at those. You have so generally, let's see how many boxes we need to fill. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So totally we have a 60 ions formulas you're going to write on over here. So how to do this work? Okay, for example, the first one, that's a zinc 2+. And the column shows the chloride over here. Then we have a Fe3 2+. So what are you going to do? In this box is a combination between zinc ion and the chloride ion. You see, one cation and one anion. So you're going to write a formula that is combining with zinc and chloride. And this box that's gonna be combining with ions and chloride. Make sure the charge, okay, because you see the one next bar it has a 3 positive charge, and this one has 2 positive charge. Ion has a there's 2 different kind of ions. There's a one ion has a 2 positive charge, the other one has a 3 positive charge. We're going to talk about those ions has a different charge in the next class, okay? But now, just let you know, they have a different charge. If they have a different charge, when they combining with the same formula, same anion, they're going to having the different formula. Does that make sense, right? They're going to have a different formula. So please be careful when you write those. They should have a different formulas. For example, this ion has 2 positive and we have a 1 negative charge, which means we need to have a 2 of this negative charge to balance with 3, the 2 positive. So the formula will be FeCl2. But this one, you're gonna write FeCl3. Then because they have a different charge, so when you write the formula should be different. Okay, when you write the formula should be different. So generally, this is how you write this question. Totally, we have a 60 box. So you're gonna fill all the 60s. Once you're done, please check with me. Okay, yeah, I need to make sure you got it right. Okay, not finish everything, but make it right.